My name is Joshua Mugabi. I welcome you to topic 4, respiration. Our learning outcome B. Analyze the biochemical processes leading to ATP production in living organisms and how these processes are affected by physical activities and respiratory poisons, cyanide. Details of biochemistry are not required. We are looking at the learning activity F. In groups, learners search for how ATP production changes during various exercise intensity. Learners make write-ups and use gallery walks to discuss their findings. ATP production during different exercise intensities. Item 1. Let's focus on resting and light exercise. A student walks slowly to school without feeling tired. Task. Identify the main pathway used to produce ATP during rest and light exercise. Explain why this pathway is suitable. Identify the main pathway used to produce ATP during rest and light exercise. Aerobic respiration is the main pathway. Explain why this pathway is suitable. Oxygen supply is sufficient. Complete oxidation of glucose occurs. Produces large amount of ATP efficiently. Little or no lactic acid is formed. ATP production during different exercise intensity. Item 2. Let's consider now moderate exercise like jogging. A learner jogs for 20 minutes and breathes more rapidly. Task. State the dominant ATP producing process. Explain how ATP supply meets energy demand. State the dominant ATP producing process. Aerobic respiration remains dominant with the increased rate. Explain how ATP supply meets energy demand. Increase the oxygen intake. Increase the heart and breathing rate. Mitochondria increase ATP production through oxidative phosphorylation. ATP production during different exercise intensities. Item 3. High intensity exercise. Sprinting. A sprinter runs 100 meters at maximum speed and becomes fatigued quickly. Task. Identify the main ATP producing pathway. Explain why this pathway is used. Identify the main ATP producing pathway. Anaerobic respiration, that is glycolysis. Explain why this pathway is used. Oxygen supply cannot meet demand. ATP is needed rapidly. Glycolysis produces ATP quickly, though inefficiently. ATP production during different exercise intensities. Item 4. Let's now look at very high intensity and fatigue. After repeated sprints, the athlete experiences muscle pain. Task: explain the cause of muscle fatigue. State how ATP production is affected. Explain the cause of muscle fatigue. Accumulation of lactic acid. There is also drop in pH inhibits enzymes. State how ATP production is affected. ATP production decreases. Muscle contraction become less effective. ATP production during different exercise intensity. Item 5. Recovery after exercise. After resting, the athlete's breathing remains fast for some time. Task: explain the reason for continued heavy breathing. Relate this to ATP production. Explain the reason for continued heavy breathing. To repair oxygen debt. Oxygen is needed to oxidize lactic acid. Relate this to ATP production. Lactic acid is converted to pyruvate / glucose. Normal aerobic ATP production is restored. ATP production during different exercise intensity. Item 6. Comparison across exercise intensities. A teacher asks learners to summarize ATP production at different exercise levels. Task: compare ATP production at low, moderate, and high exercise intensities. State one advantage and one disadvantage of anaerobic ATP production. Compare ATP production at low, moderate, and high exercise intensity. Exercise intensity, ATP pathway, ATP yield, and characteristics. At low exercise intensity, the ATP pathway is aerobic respiration. ATP yield is high, and it is efficient and sustained. At moderate exercise intensity, ATP pathway is aerobic respiration. ATP yield is high. Characteristics: increase the rate. At high exercise intensity, the ATP pathway is anaerobic respiration. ATP yield is low. Characteristic: fast and short term. State one advantage and one disadvantage of anaerobic ATP production. Advantage: rapid ATP supply. Disadvantage: low yield lactic acid accumulation. Marking the emphasis. Correctly identify ATP pathways. Explain physiological changes with exercise. Relate oxygen availability to ATP production. Use correct biological terminology. Apply knowledge to real-life exercise situations. Summary: ATP production during exercise depends on intensity. Low and moderate activities rely mainly on aerobic respiration, producing the ATP efficiently. High-intensity exercise depends on anaerobic respiration, which provides rapid but limited ATP and leads to lactic acid accumulation and fatigue. Thank you very much for participating in topic 4, respiration. Our learning outcome: B, analyze the biochemical processes leading to ATP production in living organisms and how these processes are affected by physical activities and respiratory poisons such as cyanide. Details of biochemistry are not required. Our learning activity F. In groups, learners search for how ATP production changes during various exercise intensities. Learners make write-ups and use gallery walks to discover their findings. If this has been useful, visit me at Mugabi Joshua Biology on YouTube.